Solve similar figure applications. Now, the biggest thing with similar figures is knowing what they are. So similar figures, if two figures are similar, if the measures of their corresponding sides have the same ratio. So if we would have two rectangles, so corresponding sides, so like a width and a width would be corresponding sides, and a length and a length. So we could say if we had 2, 4, and then like 6, 12. Okay, because we could say corresponding sides. 2 is to 4 as 6 is to 12, right? We have the small rectangle on top and the large rectangle on the bottom. And we can see that this is an equal proportion, because if I would cross multiply, 6 times 4 equals 2 times 12, right? They're both 24. So this would make them similar. So it's all about the corresponding sides. So let's just do two basic examples. I have triangle ABC, so A, B, C, yes, order matters, is similar to triangle DEF. So notice that AB is first DE. That means AB is corresponding to DE. BC, the last two, is corresponding to EF. So BC corresponds to EF, and then AC, so AC corresponds to DF. That's how it works when you're dealing with triangles. So we want to find the length of EF. So we're going to find this. Okay, so pardon all the scratches, but we can see, okay, we just need a proportion, right? We just need two ratios. So I'm going to use the red side, right? AB to DE. So AB to DE. So I'm going to put the left triangle on the top, the right triangle on the bottom. You have to be consistent. Then I'm going to use the right side. So the left triangle on the right side has a side of 7. The right triangle has that side of X. Now that we have our proportion set up, we can go ahead and solve. Now do notice that side BC, this side here, is smaller than AB. That means our side of X, EF, length of EF, should be smaller than 24. Okay, let's go ahead and cross multiply. So 8 times X is 8X, and 24 times 7 is 168. So 168 for 7 times 24. Next, we divide both sides by 8, because 8 divided by 8 is 1, so 1x equals 21. So the length of EF would be 21. And that makes sense, right? Because it's a little smaller than 24. And if you think about this, 8 times 3 gives you 24. 7 times 3 gives you 21, right? In the same ratio. Let's do another one. Triangle MNO is similar to triangle XYZ. Find the measure of YZ. So we're trying to find N, this measure. So which side is corresponding to YZ? Well, no, it's NO. So I know that N over 18 is one of my ratios. Now in this case, we are not given this side, so it doesn't matter. We're doing 3 to 4. Because N is in the numerator, 3 will go in the numerator. And then we cross multiply. 4 times N is 4N. 3 times 18 is 54. Divide both sides by 4, and N equals 13.5. So again, thinking about this, 3 to 4, 3 to 4, a little bit bigger. If N is 13.5 to 18, a little bit bigger. And that makes sense. So the idea of similar figures is that the corresponding sides are in the same ratio, and because they're the same ratio and a proportion is a comparison of two ratios, that is why we can solve similar figure applications with proportions.